right. Okay, so first clarification is on the assignment that we had for operator overloading and indexers. Did I give you an assignment on indexers or no? Or only on operator overloading? Only operator overloading, all right, so I'll give you another assignment then. Okay, let's say you created some class, let's pretend currency, right? And you defined int, cents, int, dollars, let's pretend, and also the corresponding public get set property over here, right? Okay. And then you define public static currency operator plus currency left hand side, currency right hand side. Okay. And you wrote some code over here. So for example, your typical code will be something like this: currency temp equal to new currency, and then you will do temp dot cents equal to left hand side dot cents plus right hand side dot cents, right? Okay, and then if temp dot cents is greater than equal to 100, okay, then what will you do? You'll subtract 100 from it, right, and increment the dollars and return the temp currency, right? So so this is your typical code.
Question.
Okay.
This for the left hand side and right hand side. How does that work in? I'm still kind of confused how that works in memory.
Okay. All right. So in that case, let me. Okay, if temp dot cents is greater than 100, then you will do temp dot dollars equal to temp dot, sorry, left hand side dot dollars plus right hand side dot dollars plus 1, right? And you will do temp dot cents equal to temp dot cents minus 100. Okay, else temp dot dollars equal to left hand side dot dollars plus right hand side dot dollars and return temp. So anyway, this is what your code will be. So to clarify, what is left hand side, what is right hand side? Okay, so your test code will look something like this. You will do in some kind of a button handler. You will say currency, let's say C1 equal to new currency, let's say 5 comma 7, so $5, or let's make it 20 cents, $5 20 cents, right? Currency C2 equal to, let's say, $8, let's say 90 cents, okay? So then if you did currency C3 equal to C1 plus C2, right? Okay, so this is where the compiler checks what data type is C1. It will go back and see its currency. then it will check what is C2. C2 is also currency, right? So then it will go to the currency class and see, was there an operator plus defined? Because remember, a computer can only do addition on integers or doubles, but not currencies, unless we define it. So then it goes to the currency class and says, oh, there is an operator plus. So that means this C1 will become left-hand side, this C2 will become right-hand side, okay? So once we say currency temp equal to new currency, we are creating in the memory something called temp, which has a cents value, which has a dollars value, right? So then we do temp.send left-hand side dot send. So what is left-hand side? Which is C1. C1 in our example is $5.20. So the sent amount is 20, right? Right-hand side in our case is C2. Sent amount is 90. So it will do 20 plus 90. So this will basically become 110 in this example, right? Then we are checking, is it greater than 100? Yes, so then dollars for our temp. So temp is basically our result. Okay, so dollars in the temp amount is left-hand side dot dollars. What is left-hand side? Left-hand side is C1, okay? So it will be 5. So this will be 5 in our example. This will be 8 in our example. So 5 plus 8, 13. Plus 1, 14. So this will become 14, right? Because we had already exceeded the cents greater than 100, cents will be subtracted by 100, okay? So cents will become 10, okay? And in this case, we'll skip the else because our cents is already greater than 100. So we return temp. So you can see $14.10 will get stored over here, okay? Which is the right answer, okay? So that brings us to another question. What if somebody tried to do in the next line currency C4 equal to C1 plus C2 plus C3? What will happen? Do we have to overload one more operator plus so that instead of taking 2 parameters, it takes 3 parameters now, or the same code will work?
We have to store it in like C4 is equal to C1 plus C2 and then again add that because
Okay.
it will take only 2 parameters.
Good, yeah, that's the correct answer. So forget the currency for the time being. If you did int a equal to 5, int b equal to 7, right? And then if you did int c equal to a plus b, remember once the computer executes it, it translates it to its assembly language. Inside the CPU, there's one adder, which only adds 2 numbers, okay? So this A will be fed over here to the adders. So anyway, it will produce 12, and that 12 will be stored over here. But the main point is, in the computer's hardware, the adder can only add 2 numbers at a time, not 3, not 4. So that then the question is, what if somebody further said, let's say int c equal to 9, and somebody said int b equal to a plus b plus c. How does the computer add that? Okay, and the answer is the computer will first convert this to one assembly language add instruction. Okay, so it will do a plus b, so it will send it to the same adder, bring back 12, then call the add one more time. So think of it this way, this gets translated to add of a comma b in the assembly language, then add of, so suppose this is some temp over here, then add of temp comma c. So But at any point in time, we are only adding two numbers at a time. Okay, so same thing over here. Even if we do C1 plus C2 plus C3, what will happen? So let's take a look. Okay, C1 plus C2, C1 will be given as the left-hand side, C2 will be given as the right-hand side. So it will compute. In this example, it will do again $14.10. So then the reply will come back, 1410, and then the compiler will translate it to one more call to the same operator plus function. So then 1410 will become in the next call the left-hand side, and C3 will become the right-hand side. So there will be two calls made to the same function. So in a minute I'll go to the computer and I'll show it to you. We can just put a breakpoint over here and easily test that it makes the two calls, right? Okay, so as I had mentioned to you some time ago, when you develop software, there are two important issues. Number one, you should be able to debug your program, because no matter how good you are, you'll make mistakes. Okay, so the difference between a good software developer and somebody who's not so good is not how quickly they develop the code, how quickly they debug the code, because both of them will make mistakes, right? And of course, then you should be able to test your code, because you may not, for example, let's say we forget this condition. We forget this to write this and simply do this. So there's no else over here. We simply write temp dot dollars equal to LHS plus RHS plus dollars. And we say temp dot sense equal to LHS dot sense plus RHS dot sense. Okay, so all we are doing is simply adding the $2, adding the 2 cents, no other code over here. So let me just remove that. So just these two lines of code, right? So now if you call this function with, let's say, $5.40, $7.30, will it produce the right answer?
No.
Okay, take a look over here. Temp dot dollars equal to LHS dollars plus, so it will do 12, right? Then temp dot cents equal to LHS dot cents plus RHS dot cents, so 40 plus 30, 70. That's the right answer, okay? But if somebody triggered it with $5.20 and $8.90, will it produce the right answer? No. So especially if the code becomes a little more involved, you have to test it for many different cases, and this is where the unit testing comes into play, right? So let me go to the computer and show you how we set up unit testing. So in a minute as it comes up,